Hello again. Continuing work on reaction quotients and equilibrium constants. We have here hydrogen reacting with fluorine to make hydrogen fluoride, and the mole ratios are 1 to 1 to 2. And they tell us its equilibrium constant is big, 2100. When the system is at equilibrium, the concentrations of hydrogen and fluorine are both found to be 0.0021. Okay, so we need an equilibrium constant before we can do anything with these concentrations, or a reaction quotient rather. So for this reaction, we have hydrogen fluoride as our only product, and its mole coefficient is 2, so that gets a power of 2. And our reactants are hydrogen gas, thus, and fluorine gas, thus. They tell us the hydrogen and fluorine concentrations are both 0.0021. They do not tell us HF, so if we wrote this with every possible blank filled in, we'd get X squared. I don't know what the fluorine HF concentration is. Hydrogen is 0.0021. Fluorine is the same amount. Bit wasteful to write that twice, but it's okay. And they tell us the equilibrium constant is 2100. And now we must solve for X. We could shortcut this taking advantage of the fact that these two numbers are equal, but they won't always be equal, so I'm going to ignore a certain shortcut that you've probably noticed. I'll just inefficiently multiply those two numbers together, and we get x squared divided by 0. Oh boy, 1, 2, 3, 4, 5 zeros, 441 equals 2100. Now, pretend you're in math class. How do you solve this? If we want x alone, there are two obstacles to x being alone here. It's squared, we'll have to take that off, and it's divided by 0.00000441. The opposite of dividing by this number is multiplying by it. So if we, on both sides, multiply by the long number with all the zeros, on the left side these cancel out, and we're left with just x squared. On the right side, we have a thing our calculators can do, 2,100 times the long number with all the zeros equals 0.009261. We're still not done. We want x, and this is x squared, so the way you remove a square is with the opposite of a square. You square root both sides. On the left side, this square root and the square will kill each other, and we'll just get x. And on the right, again, the calculator can do this for us. We need the square root of 0.009261, which is 0.09623. That's the concentration of HF, so it should be in moles per liter. And last thing, the numbers we were given in both cases had two significant digits, so this should be trimmed down to two significant digits. So those zeros don't matter, but 96 is all we're allowed to keep. We don't round up because that's only a 2, so 0.096 moles per liter should be our concentration of HF. Quick one, declarative knowledge. What is the only thing that changes an equilibrium constant? If you have a system and it has a certain equilibrium constant, the equilibrium constants depend on temperature. So if you want your equilibrium constant to go up or down, the only ways to do that are warm up your system or cool down your system. Catalysts do not change the equilibrium constant, so if you don't like it, temp is the only dial we can turn that'll give us a different value. Fair enough. See you in the next one.